I'm Lisa, and this week on NASA Now, we'll meet the team chief of the NASA spacecraft that recently flew by Comet Hartley 2. But before we get to that, let's find out what else is happening at NASA Now. After undergoing major upgrades, the X-48 Blended Wing Body Research Aircraft has resumed flight testing at NASA's Dryden Flight Research Center. Join us next time to learn more about this extraordinary aircraft. Scientists involved with the first space mission attempting to sample asteroid surface material and return it to Earth have confirmed the presence of comet particles collected from a small container aboard Japan's Hayabusa spacecraft. The samples were collected 5 years ago from the surface of asteroid Itokawa and were only recently brought back to Earth, concluding a remarkable mission of the exploration in which NASA scientists and engineers played a contributing role. Now, let's take a look back at the past.
September 11th, 1985, ICE, the International Cometary Explorer, passes within 5,000 miles of the nucleus of Comet 12P, becoming the first spacecraft ever to encounter a comet.
Encountering a comet. It may sound like science fiction, but today it is science fact. Recently, scientists and engineers at NASA repurposed the Deep Impact spacecraft, which previously was used to explore the comet Tempel 1 in 2005. Then, 5 years later, the spacecraft, while in orbit around Earth, was reprogrammed and sent on a 2 million-mile journey to intercept its second target, Comet Hartley 2. The second mission of the Deep Impact spacecraft was named EPOXI. This time, the spacecraft traveled at 26,000 miles per hour as it flew by the comet at an altitude of 400 miles. The EPOXI spacecraft's encounter with Comet Hartley 2 provided scientists with amazing images and new information about comets. Here to give us a technical insight on this extraordinary mission is Steven Wissler, spacecraft team chief for the EPOXI mission.
My name's Steve Wissler. I'm the spacecraft team chief for the EPOXI mission at the Jet Propulsion Laboratory. We just flew by Comet Hartley 2 on November 4th. About 2 months before we got to the comet, we started observing it with the cameras on board the spacecraft. And then those images are sent to the ground, and the navigation team used those to help refine the orbit of the comet. We were getting constantly surprised at how much it was moving, and the inability to really nail down exactly where the comet was. Once we get within about an hour of the comet, then the spacecraft takes over and analyzing those pictures itself. It looks at the picture, where's the comet in the picture, and it recalculates the ephemeris of the spacecraft as it's flying by the comet. And that, again, further refines the orbit and allows us to point the instruments. There's certainly a lot of math and physics involved. The calculus, geometry, trig, these are all very important in order to figure out where the comet is, where the spacecraft is, and how to get their trajectories to line up. You can think of it as like firing a gun in New York and firing a gun in Los Angeles and having the bullets hit each other. That's about how difficult it is to do that particular job. Comets all originate in a cloud outside of Pluto's orbit called the Oort cloud, and occasionally they get kicked out of their orbits and they will come in closer to the sun. Typically when you see a comet, you see a coma around it where there's a lot of dust and gas in the area, and so as we fly by there's some risk that we might hit something. The tiny dust particles generally don't do too much damage, but as we flew by this comet, we were really surprised by what looked like a reverse snowstorm coming off of the comet with particles maybe as big as a softball or a basketball. So if you can imagine getting hit by a snowball at 26,000 miles an hour, it would not have been a good day. To operate a spacecraft, you have to be a jack of all trades. You really have to understand every subsystem on the spacecraft: attitude control, power, thermal, telecom, command and data handling. And you have to understand the science to some extent also. You have to understand what it is the scientists really want to accomplish. The scientists have a good idea what they want to do with the instruments. They'll tell us, I want to take these series of pictures, and we have to figure out how to actually get the spacecraft to do it. It was very exciting, though, when the images first started coming down. This comet is very spectacular looking, completely different than most other comets. The characteristics of it were pretty wild, and so everybody was really surprised. The scientists were just like beaming as soon as they saw those first pictures, because this is what it's all about. It's all about getting that science down and understanding what these comets are all about.
Did you know that the small but active comet Hartley 2 became the 5th comet to be imaged close up by a spacecraft?
Now it's time to check out what's up.
If the sky is clear and you're an early riser, look for Mercury climbing over the eastern horizon about 1 hour before sunrise. The planet Venus will also be visible, glowing majestically in the pre-dawn southeastern sky.
Today we learned about the EPOXI mission. Now it's your turn. Check out these activities and resources on the NASA Explorer School's virtual campus.
This week there are 2 great activities for you and your teammates. First, you'll construct a scale model of your own Flyby spacecraft. Then, test your Comet IQ in the Tales of Wonder quiz. If you get 8 out of 10 correct, Stardust will capture samples of the comet and bring them home to Earth. Visit the NASA Explorer School's virtual campus for activity instructions and mission resources.
Well, that's it for NASA Now. Join us next time and we'll take a look at NASA's X-48, a blended wing aircraft that features green technology. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.